Chapter 3, Section 1 is about graphing linear equations. Before we get too far into this section, I want to go over some vocab words that we're going to need to be familiar with as we get started with this new chapter. So a linear equation would be any equation that forms a straight line when it's graphed. So anytime that you've ever seen a line graphed, that was representing a linear equation. If you think about it, the word linear does have the word line in it, so it makes sense that those would be the types of equations that would be forming lines. There's something called standard form when you're talking about an equation of a line, and that looks like ax plus by equals c. A and b and c are all going to be numbers. So an example of this would be like 3x plus 2y equals 4. Something like that would be something written in standard form. Now, as we start getting into graphing these, we're going to be dealing with the coordinate plane. So x and y are going to be used a lot, and those form what we call ordered pairs on a line. And all ordered pairs are written in parentheses, with x coming first, y coming second, and there's going to be a comma in between them to separate those two terms. Some other things to know about linear equations is there's going to be times where they cross the x and the y axis on your coordinate plane. When it crosses the x axis, that's going to be known as the x-intercept. And when it crosses the y axis, that's going to be known as the y-intercept. So that's just a point at where that line is going to cross through both the x and the y-axis. Now, graphing basics, some of this you probably already know, but I just want to refresh our memory so that we're all on the same page when I start talking about graphing, and if I start describing a specific part of the graph, or I'm looking at the coordinate plane and I want you to look at a specific area. In your coordinate plane, you're going to have an x-axis and a y-axis. Those would be like the two major lines that form that coordinate plane. The one that goes left to right and is horizontal, that's going to be your x-axis. The one that goes straight up and down and is vertical, that's going to be your y-axis. Now within the coordinate plane, we have what are called quadrants, because these two lines form kind of four box areas. The one starting in the top right corner, this is going to be known as quadrant 1, and we use Roman numerals when we're labeling our quadrants. Then you go kind of counterclockwise, almost think about making the letter C here. So this one over to the left is going to be quadrant 2. This would be quadrant 3, and then we have quadrant 4 to end it off. A point that you're going to hear a lot, or a point that you're going to be referring to a lot, is the origin, which would be 0, 0. And that would be right there on the graph, right where the x and the y-axis meet. And like I said earlier, all ordered pairs are going to be inside of parentheses. I guess on this I didn't need to include those parentheses around 0, 0 since they're already there. All ordered pairs are going to be x, comma, y. So I want to see if you guys remember how to graph. So go ahead and take a minute and try to graph these points on the coordinate plane. And it might be helpful for you to maybe label the points with letters. So after you graph 3, 2, maybe put a capital A by it. The next one we'll call B, C, D, and E, just kind of going down the line there. So go ahead and try to graph those 5 points. So for that first point, for 3, 2, you should go right 3 and up 2, and that's where A is going to go. Now for B, they're both negative, so you need to go the opposite directions. You need to go left 4, down 5. For C, you go right 2, down 1. E, you're going to go left 1, up 2. And for E, it's 0, 3, so you don't go left or right any because your x is 0, so you stay at the middle, and then you go up 3 points. So it's on the y-axis. So that would be an example of a y-intercept because it's sitting on the y-axis. If there was a line maybe connecting the points D and E together, E would be the y-intercept of that line. Now, if we turn the page here, we're going to talk a little bit more detail about these linear equations. So like I said, linear equations are lines. They're going to form a straight line when you graph them. So when we look at an equation that's written in the linear form, if you actually graph on the coordinate plane, it's going to be a nice straight line. No curves, no bumps, no going up and down, no hills or anything like that on the graph. It's going to be a straight line. When you're dealing with a linear equation, you are not allowed to have variables that are multiplying together. So you are not allowed to see something like x, y. That's a no-no. You are not allowed to have variables in the denominator. So you cannot have anything that says like 1 over x or y over x or anything like that. Variables may also not have a power other than 1 or 0, so you cannot have things that say x squared or y to the third or anything like that. It has to be a plain x, a plain y. So I gave you some examples here. On the left-hand side are some examples of linear equations. You can see how all of these follow those rules. None of those examples have an x and a y multiplying together or any letters multiplying together. None of them have any letters in the denominator of fractions. Now, there is a fraction on this last one, 1/2, but the letter is not in the denominator. It's okay to have a fraction in your problem if it's just numbers. But if you have a letter in the bottom of that fraction, that's when you start having an issue. And then again, I don't see anything that says x squared, y squared, x to the third, nothing like that. They all are just regular x, regular y. Now, if you look at the other set of equations I have here, these are the nonlinear equations. So let's just go through and find what you think the issue is with all of these. So this first one right here has an x squared. And I said that you cannot have variables that have powers other than 1 or 0. So that's what causes that one to become nonlinear. Now, the second one may look like it's pretty linear, but the one that has the square root, that actually is causing it to be nonlinear. If you have something like x underneath the square root, that is actually the same thing as x raised to the 1/2 power. And again, that's a power that's not 1 or a 0. So I'm not able to have that be considered linear anymore. For the third example, x is in the denominator. That's causing the problem. And for the last one, there's an x times a y, and so you're not able to have that either. So those are all examples of equations that would be considered nonlinear. Now, in linear functions, most of the time, they are going to be written in what we call slope-intercept form. Y equals mx plus b. At this point, you should probably take a moment here and memorize that. Y equals mx plus b. We are going to be talking about that form for the rest of your math career. Anytime we're talking about graphing a line, that is the form that you're going to hear about. Now, there are other ways to write equations of lines. There are other forms that can be used. However, this is going to be the most common, the most used, the most popular form, so you need to have it in your brain because I'm going to be talking about it a lot. So if I say slope-intercept form, automatically you should think y equals mx plus b. So if you guys look at the equations that I have up above that say linear equations, I want you right now to write down on this blank from this list, so from over here, which one matches that form exactly? Which one says in that same form y equals mx plus b? We all wrote y equals negative 2x plus 3. Now, arguably, this one, y equals 1/2 x, is still written in slope-intercept form. It just doesn't have a number added or subtracted onto the end right now. It is technically plus or minus 0, but we don't normally write that if there's a 0 at the end. But I just want you to be aware that that would technically be considered slope-intercept form. However, I want us to focus on this one here, the y equals negative 2x plus 3, because I want to be able to pull some pieces of information to show you guys how you're going to graph these types of equations. So when you have something written in that y equals mx plus b, there's two really important things that you need to be able to pull. That letter m, so I'm going to write this over here, y equals mx plus b. The letter m represents what's called slope. And we'll talk more in detail about slope in a coming section, but slope is going to tell you how quickly or how slowly a line is moving and whether the line is going up or if it's going down. So that number that sits in front of the x term is always going to be known as your slope. Now the b, this is known as the y-intercept. Now why do we call the y-intercept b? A lot of times students would think, well, shouldn't it be called y? Because it's the y-intercept. And while that does make a lot of sense, we already have a y in the equation. So we had to use a different letter to represent that because the x and the y in your equation represent points on your line. They are not going to be filled in because they could be changing depending on where you're at on the line. So we use b to represent the y-intercept. So right now, looking at this equation, y equals negative 2x plus 3, let's pull the slope and the y-intercept from that. Now remember, both of these should just be numbers. So slope should be that number in front of the x, which is that negative 2. Another way that you want to maybe start thinking about this is how would you write that as a fraction? So negative 2 over 1. The reason why you're going to want to maybe write it as a fraction is so that we can start thinking about how you would use that to help you graph. And when we're graphing slope, you're going to hear us talk a lot about rise over run. And so you need to think about those two separate numbers. So if the slope is already written as a fraction, great, then it's already been done for you. But if you have a whole number like this, then you might want to write it as a fraction by putting it over 1. Now the y-intercept would be the number at the end of your equation, which is the 3. That underneath it I put starting point. And I'm going to talk about what that means, but that's going to be how we get our graphs started, like where do we begin at on the coordinate plane. So now I want to show you how to graph this. Now that you know what your slope is and you know what your y-intercept is, you've got enough information for you to be able to graph this line. So that y-intercept is going to be your starting point, and that's always going to be on the y-axis, okay? So always on the y-axis because it's the y-intercept. So remember we said that the y-intercept was on the y-axis. It's where that line crosses. So the y-axis is the one that goes up and down. So you need to go up 3 from 0, 0, from the origin. Draw your first point. That's the starting point. Now your slope is what you use to help you graph the next point. So this slope is that negative 2 over 1. So from 3, we're going to go down 2 because of negative 2. And then the 1 is positive. When you have a negative slope, only one of those numbers in that fraction needs to be negative. So I already went down 2, and I need to go right 1, because right would be positive. Now, when you do this, you can do this as many or as few times as you would like. I usually do at least a couple, so I'm going to go down 2 more and right 1 more again, just so I can get a really good idea of where this graph is going to go. And then I'm going to go ahead and connect my dots. Really quickly, I just want to point out that yes, I was going down 2 and right 1, but using this slope up here, if you ever run into a case where you graph the first point and then you're trying to graph a couple others to get your line, and all of a sudden you're running out of room. You don't have space to go down 2 and over 1 anymore. Instead of having to completely erase your graph and start all over again, you can switch the direction you went with your slope. So what I mean by that is that instead of going down 2 and right 1, I could go from that point 3, I could go up 2 and left 1. That was just making the 1 negative instead of the 2 being negative. So it's just something to know that you can use or do if you're ever running into an issue where you're trying to graph the line and you're running out of room. Once you've got some points graphed, grab a straight edge if you have one, and you don't necessarily even need like a ruler or anything fancy like that. If you have a lunch card on you or like something like a debit card from your wallet or something like that, even like the straight edge of like a notebook, your planner, something like that works really well as a straight edge or as like a makeshift ruler. When you draw the lines, they need to go through all those points, they need to keep going, and you need to put arrows on either side of your line because these are going to continue to go in both directions. Lines go on forever and ever in both directions. So make sure that you extend the lines beyond the points and you draw those arrows on either side. Before we do some more practice with graphing, I want to go over that standard form that I mentioned at the start of the section. Standard form, remember, is the ax plus by equals c. A, b, and c have to be whole numbers with the greatest common factor of 1, meaning that if you had the numbers in front of the x and the y, if the numbers a, b, and c were like 10, 12, and 16, those all could be reduced by a 2, so you would want to do that before you did anything with that equation. So if you go back to your previous examples up here, this list, which one of these equations, again over here, is written in that standard form? Hopefully we can all agree that 2x plus 3y equals 4 was written in standard form. What I'm going to do here is identify a, b, and c real quick. So those are just those numbers. A is the number in front of x, which would be 2. B is the number in front of y, which would be 3. And c is your plain number after the equal sign, which is the 4. Now, standard form, if you're ever given something in standard form, you may need to use the x and y intercepts to help you graph it. So instead of having to maybe rewrite the equation or like try to manipulate it, you could always use the x and y intercepts to help you graph those points to get your line. Now, how do we do that? Well, remember that the intercepts, like if you're still wondering, well, what are those intercepts again? That is where the line crosses the x or the y axis. Okay? What is true when you're finding the y-intercept? Well, if it's on, the x-intercept, if it's on the x-axis, then that would mean that y is going to equal 0. So if they're asking you what would be true then about finding the y-intercept, hopefully you guys can say that, well, x would be equal to 0. So what we're going to do next here is do some more practice with our graphing. We're going to first start by graphing like we did on that first example where we identified the slope and the y-intercept. So this equation that I have here is already written in slope-intercept form. It's got that y equals mx plus b format happening. Remember, your slope is the number that's in front of the x, which would be the 4. And your b would be the number that's at the end of the equation, which for that one is -3. Now remember, for slope, the 4, you might want to think of that as, how would we write 4 as a fraction? 4 over 1, because we're going to use that for our slope. So now let's graph. So your b is -3. So from 0, 0, you're going to count down. 1, 2, 3, and draw your first point. Then for your slope, 4/1, from that -3 that you just graphed, you're going to go up a +4 and right +1. And again, you can do that as many times as you'd like. So if you want to include another one on here, you're going to go up 1, 2, 3, 4 again, and over to the right again. Then you're going to connect your points. I'm going to try to do mine again. It's a little harder on here for me to freehand those, but I'll do the best I can. And there's your line. So I want you guys to practice this here. So go ahead and start with this practice problem. Graph y equals 2x plus 5. Start by identifying your slope and your y-intercept, and then go ahead and graph. So your m, your slope, should have been 2, which you might have wanted to rewrite as 2/1. Your b, your y-intercept, is going to be 5. For this graph, I would have started up at +5 on the y-axis. So from 0, 0, go up 1, 2, 3, 4, 5. And then for my slope, I would have went up 2 and over to the right 1. Or, to practice what we talked about earlier, if you're running out of room, maybe to do some more points like I am, I could go down 2, left 1. You can go the exact opposite direction of what your slope said in order to get another point on that line. Again, make sure your line extended through those points and you have arrows drawn on either side. Go ahead and try this next practice problem on your own. So for this one, m should have been 2/3. b should be -5. Now, slope is already written as a fraction for you, so you did not need to try to write that one as a fraction. To graph, I would have started down at -5. And then I would have went up 2 and right 3. Or again, you could have gone down 2 and left 3. Now, I also want to practice with you guys how to use the y-intercept form. So, if you don't have the equation written in that y equals mx plus b form, one thing you could do is you could figure out how to do that. So you could rewrite this equation in slope-intercept form, which we will require you to do that at some point. It's not a necessity right now for you to do that. So instead, what we could do is graph this using the x and the y-intercepts. Now, in order to do that, to find your x-intercept, you are going to take this equation and you're going to replace the y with a 0. So in my equation here, I've got -2x plus y, but instead of y, I'm going to put 0 and set that equal to 6. Now, -2x plus 0 is just going to be -2x, and I have that now equal to 6. I'm going to divide by -2, and I'm going to say x equals -3. Now, in order for you to graph that, you have to think about, well, what would that be as a coordinate? In order for me to have found -3, I had to put in a 0 for y. So the x-intercept is always going to be the number x that you found, and then 0 for the y. Now we're going to do something similar here, but to find the y-intercept. So to find the y-intercept, you are going to set x equal to 0. So maybe up here let's write set y equal to 0, just so that you remember to do that. So again, in my equation, I've got negative 2x, but instead of x, I'm going to put in a 0. And I always put it around in parentheses like that, just to kind of remind you that you're taking negative 2 times 0, and then plus y equals 6. Well, if I take negative 2 times 0, that's gone. And I'm left with y equals 6. And so as a coordinate, this one, the x was 0, and your y was 6. And so there's your y-intercept. So to graph these types of problems, you are going to graph those 2 points that you found. You're going to graph negative 3, 0, which would be going to the left 1, 2, 3, because that's got no y movement, so you're not going up or down at all. And for the y-intercept, you're going to do 0, 6, which means that you're going to go up 1, 2, 3, 4, 5, 6. You're not going to go left or right any on the x-axis. And those 2 points are enough for you to be able to grab your straight edge, connect the dots, and make a line. So what I want you to do now is practice graphing this one using that x and y intercept method. Okay, to get me started here, remember to find your x-intercept, you set your y equal to 0. To find the y-intercept, you set the x equal to 0. So for this first one, it should have looked like 3x minus 0 equals 9. So you should have had 3x equals 9. So x should have been 3. As a coordinate, that would be 3, 0. For the y-intercept, you should have had 3 times 0 minus y equals 9. 3 times 0 is 0, so we should have had that minus y, or negative y equals 9. Now you do need to get rid of that negative sign, so you should have divided both sides by negative 1 to make this say y equals negative 9. And so as a coordinate, that would be 0, negative 9. Then you should have graphed this one as well. So 3, 0 would be going to the right 3. 0, negative 9 would be going down 9. And then again, you just need to connect your dots, draw that line, do the arrows just like before. This last method, when we are doing graphing, is you can graph something by using a table. In class, if you were with me in class, I am going to, on my screen here, I'm going to pull up my calculator. In class, I have those yellow calculators that are going to look very similar to the calculator I'm going to have up here on my screen once this loads. As we go through these examples, I want you to practice and kind of follow along what I do here so that you can see how I type this in and how I find the points that I need for me to graph. These calculators make this type of problem super simple because the calculator is going to do the majority of the work for you. You just need to know how to type it in. These problems want you to solve and graph the equation by making a table of values. Now, the equation that we have for this first one is this 2x plus 3. Now, you are not required to use the table function on this calculator to do this. You could very easily manually plug in all of these numbers one at a time. And I showed you how to do that with that negative 2 here. You put negative 2 in for the x, and you just take 2 times that negative 2 plus 3, and we got negative 1. So I've already shown you kind of how to do it manually here. Now you could continue to do that for the rest of these. You could take 2 times negative 1 and add 3, 2 times 0 and add 3, 2 times 1, add 3, 2 times 2, add 3. Now, is there a reason why I'm doing negative 2 to positive 2? Not really. It's just going to give you a good spread of points. You could do any numbers that you wanted into that x. But I would maybe stick to numbers that are going to be easy for you to graph, okay? So most of your graphs are going to have a range of negative 10 to positive 10 on them in both directions. So I would not be doing anything super crazy like putting in 20 or 25 or anything large like that, because then you're not going to be able to graph it. Now I'm going to show you how to do this on a calculator, but in order for this to work on a calculator, you are going to want to be able to rearrange the equation that they gave you. So you're going to want to solve for x, or solve for y before you try to plug this into an equation. Now, last chapter, when we were talking about literal equations, we practiced doing problems like this, where you were solving for a letter. You weren't getting something like y equals 5, though. You were getting a new expression, and that's what we're doing on this problem here. So I've got y minus 3 equals 2x. I want to get y alone. So what I'm going to do is move that minus 3 over by adding it. I'm going to write this over here. So I'm going to get y equals, now for these types of equations, think about that slope-intercept form. Y equals mx plus b. We always like the x term to come first. So it's going to be y equals 2x plus your 3 for that one. You always want the x to come first and then your plain number. All right, so now let me show you how you do this on a calculator. So when you're on the calculator here, you're going to want to start by pressing the table button, which is right here next to your clear button. So everyone press the table. Now if there's already something typed in there, you need to clear it out. Now we're going to plug in that equation that we had, which said 2x. Now x is the key right next to the 4, right to the left. And then we have plus 3. So everyone should be able to push those buttons just like I did. Follow the sequence up here to get it to look like that. Now once you've got your equation written, you're going to hit enter. For your start point, I would start with that first number that we put in our chart, which was a negative 2. Now your negative sign is down here by the enter key. So negative 2 is where I'm going to start. You're going to want to leave everything else as it looks right here. So leave the step on 1 and leave that auto option selected. So all I do is I press enter a couple of times until I get down to the OK. And then I'm going to go ahead and press enter one last time. And it's going to pull up this XY table for me. So it's already going to do all of that operations that I had typed out here in the middle. The calculator is going to do all of that for me. You can see that first point, I had negative 2 in for my x and I got negative 1 for my y. And on my table, I see that happening. Negative 2 for my x, negative 1 for my y. So going down the y column here, and you can use the arrows to kind of go up and down through your chart to get those other points. We should be able to grab all those y values now to fill out the rest of this chart. So at negative 1, we had positive 1. At 0, it was 3. At 1, it was 5. And at 2, it was 7. All of these are going to be written in parentheses as coordinates. So this is going to be negative 2, negative 1. This is going to be negative 1, 1, 0, 3, 1, 5, 2, 7. The last thing now is you're going to take those points and you're going to graph them. So left 2, down 1 for negative 2, negative 1. Then we go negative 1, positive 1, 0, 3, 1, 5, 2, 7. And you should see how they're forming that nice straight line. Now, there's a couple follow-up questions here for this problem. It says, if the x-axis represents hours, and if the y-axis represents feet of water in a pool, what does the above graph tell you? So as that graph is increasing over time, so as the more hours pass, the pool is going to be getting more and more full. So I'm going to write that. Over time, the pool is getting more full. Okay, another question says, how many feet of water would be in the pool after 4 hours? 4 hours would be an x value. So to find that, using that equation that we have up here, that y equals 2x plus 3, I'm going to take 2, and in for x, I'm going to put the 4, and then add 3, and so this would be the same as 8 plus 3, which would be 11. And that would be in feet because the y was feet. So that would be 11 feet of water in the pool. So what I want you to do is try to do the practice problem that I have here. Use the calculator to help you make your table. And then I want you to follow or do the follow-up question. And I just want to remind you that the first thing you need to do here is rewrite this equation for the y. So I want you to think for a second, how would you do that? So you need to move that 3x. So what you should do is subtract 3x from both sides. You're going to have y equals negative 3x. Remember, the x always comes first, plus 1. So now go ahead and try to finish this problem. Now again, for this one, you could have easily manually done all this work. If you had one of my calculators though, you could easily go back in, press that table button again, clear it out, type in this function. So negative 3x plus 1, started at negative 2 once again, and get to your table to get all those values. So to fill this out, we should have had 7, 4, 1, negative 2, negative 5. Then we should have graphed it. I'm going to have to kind of scroll up here, and this is going to run into my other work. So negative 2, 1, 2, 3, 4, 5, 6, 7 is up here. Negative 1, 4, 0, 1, 1, negative 2, 2, negative 5. So there's your line. Now the follow-up question says your graph represents the depth of a scuba diver after every second. What is his depth after 3 seconds? So again, you would take negative 3, again I'm using the equation here, times 3, that's the seconds, and then plus 1. And so that would be negative 9 plus 1, which would be negative 8 feet.